In this tutorial, we'll build a basic enemy AI that patrols between points and chases the player when detected. We will develop it in steps, starting with setting up patrol points and adding player detection later. Create a new scene with a character body 2D node for the enemy. Add a sprite 2D for the enemy's visual representation. While the sprite node is selected, drag your chosen sprite into the texture field of the inspection. Add marker 2D nodes as children of the enemy node to define patrol points. Each marker 2D acts as a target position for the enemy to move to. Position these marker 2D nodes visually in the scene editor to create a patrol path. Let's add 4 markers to the scene for now. We will now write a script to make the enemy move between the patrol points. Select the character controller 2D node and rename it enemy. Now attach a script. Let's remove the boilerplate script. This line tells Godot that this script is controlling a character body 2D, which will allow our enemy to move using built-in movement functions like move and slide. This sets the speed at which the enemy will move. This variable will hold a list of patrol points, in this case, marker 2D nodes. We are using @export to allow us to drag these markers directly into this array from the editor. This keeps track of the current patrol point the enemy is moving towards. In the ready function, we check if the patrol points array is empty. If we forget to assign patrol points in the editor, this will print a warning in the output. Within the process function, which runs every frame, we will call the patrol function, which we will define next, to make the enemy move between the patrol points. After that, we call move and slide, which is a built-in function in Godot's character body 2D. It moves the enemy based on its velocity vector, which we will update in the patrol function. Now let's create the patrol function. We first check if we have any patrol points assigned. If not, this function does nothing, which prevents errors if patrol points are not set up. Now we get the position of the current patrol point the enemy is moving towards. The patrol point is retrieved from the patrol points array, and we use position to get its position in the game world. For velocity, we calculate the direction to the target by subtracting the enemy's current position, from the patrol point's position. We normalize this vector to ensure the enemy moves in the correct direction at a consistent speed. Finally, we multiply it by the speed variable to control how fast the enemy moves. Next, we check if the enemy is close enough to the patrol point, within 10 units. If so, the enemy will switch to the next patrol point. This increments the current point index to move to the next patrol point. If the enemy reaches the last patrol point, this line resets the index back to 0, making the enemy patrol in a loop. Now, in the scene view, let's drag the marker 2D nodes into the field we created to hold them. Let's test this by saving the scene and running it. Now we'll add player detection, so the enemy chases the player when they come close. We will achieve this by adding an area 2D to the enemy for player detection, and modifying the script to handle switching between patrolling and chasing. Under the character body 2D node, add an area 2D. Under the area 2D node, add a collision shape 2D. This will define the area in which the enemy can detect the player. You can use a circle shape 2D or rectangle shape 2D depending on the detection range you want. Make it larger than the enemy sprite. Let's go back to the script. First, we need to add a reference to the player and the detection area. We also need to keep track of whether a player has been detected. This line sets up a reference to the area 2D node that we added under the enemy. This variable will hold a reference to the player if they are detected. We initialize it to null, meaning no player has been detected yet. We need to detect when the player enters or exits the detection range by connecting the area 2D signals. This connects the body char entered signal of the area 2D to the onPlayer detected function, which we'll define next. This function will run whenever any body, in this case the player, enters the detection area. Similarly, this connects the body exited signal to the onPlayerLost function, which will run when the player leaves the detection area. Now, we define the functions that will be called when the player enters and exits the detection area. This function is called when any body enters the detection area. We check if the body's name is player, and if it matches, we set the player variable to this body, meaning the enemy now knows where the player is and can chase them. This function is called when any body leaves the detection area. We check if the body that left the detection area is the player. If so, we reset the player variable to null, meaning the enemy will stop chasing and resume patrolling. Now, we modify the process function so the enemy can switch between patrolling and chasing the player. If the player variable is not null, that means the player has been detected, and the enemy will call chase player to follow the player. If the player variable is null, the enemy will continue patrolling by calling the patrol function. We need to define the chase player function, which sets the enemy's velocity to move toward the player. This line calculates the direction from the enemy's current position to the player's position, just like how we calculated the direction to patrol points earlier. Now let's add a simple player script to test the enemy's behavior. The player character could be built however you like, but for the purpose of enemy detection, make sure it is called player. Here I will quickly set up a player with as a simple movable character controlled by the user using the arrow keys. It is built using a character body 2D node, a sprite, and a collision shape. The script lets me control the character using the arrow keys and will be included in the description. Now let's add a main scene with a node 2D as the root. Add in the player scene and the enemy scene. Move the player so they are away from the enemy, and let's run this to see how it works. Now, it's a little weird to have the enemy waypoints within the enemy scene, so let's go into the enemy scene and delete those nodes, along with the array in the inspector. Save this scene. Back in the main scene, let's add in a couple marker 2D nodes and assign them to the enemy in the inspector. If we run now, the enemy will follow these markers and react to the player. I hope you've enjoyed this tutorial, and don't forget to like and subscribe.